There we go. All right, on this worksheet, this Reteaching 6.2, just wanted to give you an example for the top portion and the bottom portion so we're all on the same page for how this goes. Reminder that this top portion, we should be writing it in standard form. So when it asks you to write a polynomial for it with the given zeros, it should be in standard form. If we're all writing it in the same way, it should be nice and easy to make sure we're all getting the correct solution. You'll probably have to do this work on a separate piece of paper because it's a fair amount of stuff. And let's make sure we've all crossed off number 9 and number 10. Those are repeats from number 3 and number 4, so we don't need to do them twice. Certainly not. So we'll look at one example completely all the way through together. Let's take a look at number 2 together. It gives us the zeros at 1, 7, and -5. So these are the zeros. We need to turn each of those zeros into a factor. And to do that, if we start with a zero like x equals 1, to turn it into a factor, we just need to get it equal to 0. So to get this one equal to 0, I need to subtract 1 from both sides. So the factor is actually x minus 1. Now I'll go ahead and work through each of these steps for each of these factors, but I have a feeling that by about the 4th example that you've done with this, you will realize that all we're really doing to change from a 0 to a factor is just putting an x in the front and flipping the sign that we have there. Now I'll show you a case where we do have to do some extra steps, but we can always go back to this x equals negative, or x equals whatever the 0 is, and then set it equal to 0. Are there any questions about that step, first of all, going from a 0 to the factors? Awesome. Once we have those factors, we will just multiply them all together and put it into standard form. So in multiplying these first two factors together, I'm foiling, so my first two terms, x squared, my outside terms, negative 7x, inside terms, negative 1x, and my last two terms, negative 1 times negative 7 is a positive 7. I still have this x plus 5 that I need to multiply it by. And I like to combine like terms, so I have fewer terms to multiply, less chance for mistakes. So I'm going to add this negative 7x, I'm subtracting another 1x, so that gives me a minus 8x. And now when I multiply this by x plus 5, I'll again go through and make sure I'm multiplying every term together. So I have x squared times x, x to the third, x squared times a positive 5, positive 5x squared. My second term in this first set, negative 8x times positive x, negative 8x squared. Negative 8x times a positive 5, negative 40x. And now I'm multiplying this 7 by my two terms here. 7 times x is a positive 7x. 7 times 5 is a positive 35. Now I'm just combining like terms, and this will be my final answer. I have an x to the third. When I combine these two, 5x squared, and I'm subtracting 8x squareds, I'll have a negative 3x squared. Negative 40 plus 7x is going to give me a negative 33x, and then a plus 35. I double check that it's all in standard form, my highest degree first, and then all my degrees are just moving downward each time. So that's looking like standard form. Any questions about this example that we've gone through? All right. A couple other little cases I just want to bring up so that you know. If we ever have one where where one of the zeros is 0, that just means we're going to have an x. So with 7, we'll have an x. A second factor, if my 0 is negative 8, what is the factor? Yeah, x plus 8. And if I have a 0 at 2, the factor is x minus 2. We're just, if it's a simple 0 like this, we can just change the sign and put it into factored form. So now I'll go through and FOIL this one out. So this is what our factored form looks like in number 7. You'd still have to put that into standard form. And then anytime we see something, I want to go over one of these fraction ones with you too. Number 11, if you see a 0 that's a fraction like this one is -3/2, we're not going to just have the factor be a +3/2. We don't really want to do that. If I set that as a 0 equal to x, and I'm saying, hey, I want to get x, or I want to get this equation equal to 0, we're going to do this in 2 steps. The first step is to multiply everything by 2 to get rid of that fraction. So I'll have 2x equals a -3. And now I'm going to add 3 to both sides. So the factor, turning this 0 of -3/2 into a factor, is 2x plus 3. So here is what my factor looks like. Wanted to make sure we covered that so we don't end up with a bunch of fractional coefficients. And doing it this way, here's our factor that we'll use to multiply it, and it looks like we have 2 other zeros, so we'll have 2 other factors that we'll be getting. Any questions on that idea of a fractional 0 and how we're turning that into a factor? Lovely. Anytime it tells us we have a multiplicity, and this is one of our new ideas from section 6.2, it just means that it shows up 2 times. So whatever the multiplicity is, if it has a multiplicity of 2, this -2, 0 shows up 2 times. So we'll have a 0 at 4, at -2, and at -2. That means we have factors at x minus 4, x plus 2, and x plus 2. We do need to still represent that it's here twice, so when we FOIL it out to get it in standard form, we're seeing something to the 3rd degree. So we worked through an example from the top portion of this worksheet. Down in the bottom portion, it has it all in factored form for you. You're just turning each of these factors into zeros. And anytime you see something squared like this one here in number 24, this would be a good one to do together. To find the zeros of each function, this will go much, much faster for you, because we're just going to set each of the factors equal to 0 and solve for x. If it is a 0, I should be able to get that, set it equal to 0 and figure out what the x would be. So if I add 4 to both sides, x squared equals 4. What is 1 square root of 4? 2. What's the other square root of 4? -2. Awesome. So when I square root both sides here, I'm going to find that x is 2 or -2. Now I've got this other one here where I have x plus 3. Set that factor equal to 0. X would be a -3. Here's the 0. This squared number right here, that's what's telling me the multiplicity. So when I'm listing out the zeros for number 24, I'm going to say we have a 0 at 2, at -2, and at -3. Those are my zeros. And this one has a multiplicity of 2. It's the 2nd degree, so there's 2 of them. 2 factors like that. So here's my final answer for number 24.